Hello everyone. In this video, we are going to look at this example where we are going to convert this NFA to a DFA. So here, as you can see, our input symbol consists of A and B, small a and small b, and we have some epsilon transitions. So as per our transition, let us first draw the transition table for this. It will have quite a many states. So 1, 2, 3, 4, 5, 6, 7 and 8. And here we have input symbol A, input symbol B, and we have epsilon. So 1 on A does not go anywhere, 1 on B does not go anywhere. Whereas 1 on A, epsilon goes to 2 and 6. 2 and 6. Similarly, 2 on A goes to 3. 2 on B does not go anywhere, and 2 does not have a epsilon transition. 3 again on A, no transition. 3 on B, no transition. 3 on epsilon goes to 4. Then 4 on A does not go anywhere. 4 on B goes to 5. And 4 on epsilon, it does not have any epsilon transition. 5, again no transitions on A and B. On epsilon goes to 8. 8 is our final state. 6 on A goes to 7. 6 has no transition on B, and 6 does not have any epsilon transition. And 7 has no transition on A, no transition on B, and on epsilon it goes to 8. And 8, so 8 here doesn't go anywhere else, and we have our transition table as you can see out here. So now in the next step, let us construct the epsilon closures of each of these states. So as I have already constructed out here, you can see for state 1, the epsilon closure is 1 to 6, and you can see why. Because for state 1, on epsilon it goes to 2 and 6. So 2 and 6 are included here. 2 and 6 are included here, and 1 because always the closure will contain the state itself. Similarly for 2, it is, you can see 2, there is no, it does not go anywhere on epsilon. So it is only 2. Similarly for 3 and 4, 3, it is 3, 4 and so on. So we have constructed the epsilon closures of each of the states of the NFA. Next, now we start with the new start state of our DFA. So as you can see here, this was our start state of the NFA. So this was our NFA start state. And its epsilon closure was 1 to 6. So this 1 to 6 now will be our new start state. So new start state means the start state of the DFA. Okay. So now what we are going to do in the next step is we are going to create the transition table for the DFA. And to do that, let us have a state like this, table like this. So on this side I have the state. All right. And if we go back here, we can see our input symbols are A and B. So in our transition symbol for the DFA, we will have input symbol A and we will have input symbol B. 2 columns for each of the input symbols. And epsilon obviously will not appear here because the DFA does not contain epsilon transitions. So we start with our new start state, which is 1, 2 and 6. Now what do? We go back to our transition table of the NFA and we look at the transitions that 1, 2 and 6 takes on A. So we go back here and I'll just remove this just to make some space. So here you have 1, 1, 2 and 6. So we'll see 1, 2 and 6 takes which transitions are taken by 1, 2 and 6 on input symbol A. So 1 nothing, 2 takes 3 and 6 takes 7. So what we got was this 3 and 7. So on A, 1, 2 and 6 on A goes to 3 and 7. Similarly, 1, 2 and 6 on B, we will see where does it go. On B, nothing, B nothing here and B nothing here. So it is empty. So on B it does not go anywhere. Okay, so 1 to 6 on A goes to 3 and 7. 1 to 6 on B goes to nothing. So our next step according to the algorithm is that we have to take the epsilon closures of 3 and 7. So let's look at the epsilon closure of 3. Epsilon closure of 3 is 3, 4 and 7 is 7, 8. So 3 and 7, 8. So what we get? Epsilon closure of 3 and 7 is 3, 4, 7, 8. So this would be our transition here. 3, 4, 7 and 8. So 1 to 6 on A will transition to 3, 4, 7, 8. And B, we got the 1 to 6 on B goes to nothing. That means there is no transition on B on the states 1, 2 and 6. So we don't have to take the epsilon closure of that. So it is empty. Now here we got a new state. From this start state we got a new start state which is this. Not a new start state, we got a new state which is this 3, 4, 7 and 8. So now we will write 3, 4, 7, 8 here. 3, 4, 7 and 8. And in the same manner now we will compute what would be the transition on A and B for this new state. So 3, 4, 7, 8. Let us go back to the transition table and see. So I have 3, 4, 7 and 8. So let's see on A. On A we will get 3, 4, 7 and 8. So nothing, no change. On B it would be 3, that is, so here we have a transition 3, 4, 7 and 8. So we get 5. So 3, 4, 7, 8, we get 5. So now for A, since there is no transition, its epsilon transition is also empty. So empty. But for B, we got a transition at 5. So we take the epsilon transition of 5. So epsilon transition of 5 is 5, 8. So here on B, it will transition to the state 5, 8. So again now in this step also we found a new state 5, 8. So 5, 8 now appears here. So 5, 8 appears here. So again we will repeat 5, 8, transition on 5, 8. So on 5, 8, what do we get? 5 on A, no transition. 8 on A, no transition. 5 on B, no transition. 8 on B, no transition. So neither on A nor on B there is any transition. So we will put the transition diagram, the transition table. We'll mark this as empty. So what I have here now, there's no more new states which are generated. So this is the transition table of our DFA. And we got how many states? We got 3 states. The first state is a combination of the old states of the NFA, that is state 1, 2 and 6. Okay, so we can draw it like this. 1, 2 and 6 here. This is the new start state. Then we have the next state is 3, 4, 7, 8. So 3, 4, 7, 8 appears here. Okay, and we have the other state, that is 5, 8. So we have 5, 8 out here. So 3 states of our DFA. And what are the transition? 1 to 6 on A. 1 to 6 on A goes to 3, 4, 7, 8. So 1 to 6 on A goes to 3, 4, 7, 8. 3, 4, 7, 8 on B goes to 5, 8. So on B it goes to 5, 8. And which will be our final states? The final states will be the one which contains the final state of the NFA. So NFA final state was 8. So these 2 states contain 8. So these two contains 8. So these 2 will be our final state. So what we have here now is our DFA. So you can see that there are no epsilon transitions, and on a given input symbol there is only one transition. There's not more than one transitions on the same input symbol for a given given state. So this is how we get our DFA.